Now let's take a look at another type of boring using an end mill. We've showed you secrets of drilling, reaming, and tapping and boring. Now let's see what an end mill can do if we don't have a drill of a specific size or the hole diameter. It's not really critical. Watch closely. Go ahead and remove Farmer John's part. We've got a piece of extruded aluminum that we need to bore a couple of holes in. We'll set it up on our parallels. Clamp it tight, remove the parallels. We don't want to run our end mill down into the top of the parallels because the parallel usually wins and the cutter loses at that stage of the game. Okay, let's go ahead and install our drill chuck because we can rough the hole out by using a drill. For those of you that didn't fall asleep during the boring operation that we just performed, anytime we drill a hole, we need to do what? You guessed it, use a center drill. Okay, so we're going to go ahead and install our center drill, push it up against the top plate, retract it 30-40 thousandths, and we'll go ahead and locate our hole. You can see how fast the Albrecht chuck is. If we had to look around for the chuck key, by the time we had that done, we could have changed 3 or 4 drills in the Albrecht. Okay, you see we've got a long stringy chip. Take your time and uncoil it by hand. Be really careful, don't jerk it, and by all means don't get your hand next to it if the drill is running. Alright, so we've roughed out our hole to 15-30 seconds. Now let's go ahead and use an end mill to enlarge the hole to 3/4 of an inch. In order to get an accurate hole when we are boring with an end mill, we need to turn it in back gear a little bit slower than we normally would for a milling or facing operation. Use plenty of fluid and make sure that we raise the knee on the Z-axis in order to let the cutter remove material. For an accurate hole, we don't want to be feeding the mill cutter down with the quill. We'll set up some chatter if we try and do that, simply because of the surface area. So we've got it running in back gear. If we're careful and we want to apply a little bit of tension to the gib on the quill, we can do that, but I prefer to use the knee. Go ahead and bring our cutter down, contact our workpiece, back it off 5 or 10 thousandths by lowering the knee. Okay, and we're going to turn it in back gear at around 325, 200, well, let's go 210 RPM. That sounds like a pretty good number. Engage the necessary levers in order to switch the machine into back gear. Put on your safety glasses, grab your oil bottle, and we're ready to flip the switch. I'm going to apply a little amount of oil, and then we're just going to start raising the bed, clearing the chips as we go. When we clear a chip, we just simply back off and allow the chip to break free from the flutes of the cutters. Go 50, 60 thousandths at a time, depending upon the chip load that we're pulling. All right, we've bored a very accurate 3/4 inch diameter hole using an end mill. Now let's try the same thing by the use of the quill. See if we can develop a little bit of chatter showing you what that looks like. Okay, we've got a nice polished hole. Everything works out really good. Let's take a measurement while we're at it and see just how accurate that hole is. Looks like we've got a undersized end mill there a little bit. I must have had that in the shop for regrind. But we get 738 thousandths. Now let's clean the mill cutter off and take a measurement across the two cutting flutes. And I get 737. So as best we can measure using the dial calipers, we've only increased the diameter of that hole approximately 1/1000 of an inch, which is more than adequate for most boring operations that we would be doing of this nature. Okay, now let's go ahead and repeat the process and try feeding that cutter down in back gear by using the quill and see what happens. So just give you a little more practice for changing collets, center drilling and drilling. Okay, let's index our hole. In order to get a really round hole, by round we're talking really precise now, just not a round hole that a bolt goes through, you really need to drill, ream, or drill, ream, bore in that order. Okay, if you've got to have a very precise hole, reaming is probably your best bet. If we're dealing with large diameter holes, obviously we can't buy a 6-inch diameter reamer. Then boring or lapping come into play. Okay, what happened there? For all of you that was listening and paying attention, we heard a tremendous amount of chatter take place when we brought the drill in contact with our work. You guessed it. We had the RPM just a little too fast. Okay, we're running that drill at around 1750, taking a pretty heavy cut. Let's slow it down to 1100 where it really belongs and try it again. Remove our chips. Now listen closely. See how much smoother that sounds? Again, that was an application where the machine was talking at us. Hey, hey, hold it. You're going a little too fast. Slow her down. All right, now let's insert the end mill. And continue with this boring process. Okay, again, we're going to run the same RPM in back gear at 210. So we're going to make an adjustment in the pulleys. Shift gears from direct drive to back gear. Okay, we're going to go ahead and bring the cutter down against the workpiece. Back off about 5/1000ths. We're just going to apply a tiny bit of drag on the quill. Apply some oil and let's see what happens. Okay, we can use that very successfully. A little bit of drag applied. Using the end mill to bore a slightly larger hole in a plunge cut fashion. Okay, we're not getting much chatter, that's just the whine out of the gear. If we were to turn it at any faster RPM though, during a hand feed from the quill, we're probably going to pick up a little bit of chatter. All right? So that pretty well concludes our session on boring. I hope that you've learned some things and that you've already got that catalog out purchasing the Criterion boring head. We've shown you different applications. We've shown you how to use the power feed. I think you're pretty well prepared to grab a piece of stock and get with the program. All right, our next step in our practice block involves turning the block upside down. We're going to put our 4 dowel pinned holes on the bottom. We're going to dial indicate the center hole, and then we're going to counterbore that with our Criterion boring head to a diameter of 1 inch and 50 thousandths and a depth of 700 thousandths. I'm going to be using the coax indicator. If you don't have a coax indicator, grab your dial indicator and get with it. All right, I'm done. How about you? Before we get started with the boring operation, I'm going to show you a little tip on how to carefully gauge the depth of our hole. We're going to bring our boring head down in contact with our workpiece. Lock the quill in place, and again we're going to use our quill stop. We'll be boring this hole with a power feed, or you can do it manually, whatever you're most comfortable with. But we're going to bring our quill stop up, insert our gauge block at 700 thousandths, lock it into place. This way, either manually or with the power feed, we know when we've achieved the right depth. Another tip is to make a gauge block out of a small adjustable parallel. Simply adjust it to whatever depth we want, lock down our lock screw, and now this becomes our master or our gauge block to insert between our quill stop. Bring our lock ring up, lock them in place, remove that, and we're located within just a few thousandths of the proper depth. Okay, we're going to go ahead and feed this manually. And then we'll switch over later on and do it with the power feed so you get a feel for both. Or cut our little shot of WD-40. You can take around 50 to 60 thousandths per pass, roughing out the hole. Now for those of you that think you're a little bit smarter than the average bear, I don't want you cheating and running a 1-inch end mill down the hole first. The significance of this is learning to use the boring head. Stop and clear those chips away. Don't let them build up on you. Okay, let's take a check and see how close we're getting. We're at around 925 right now. Remember, our hole diameter is 1 inch and 50 thousandths. Okay, now we're going to go ahead and engage the power feed. We'll try a couple of passes on the power feed. We're at 965, so we're starting to get pretty close. Okay, we'll take a minute, we'll grab the air hose and clean out our hole. Try and get a pretty accurate dimension here. Remember to be very gentle on the air hose. We don't want to blow chips clear across the shop. We don't want to blow them into somebody that's standing across the room admiring our handiwork. Okay, we've got a hole diameter of 1 inch and 26 thousandths. We've got 24 to go. We'll go ahead and sneak up on that. We'll take it in a couple of passes. Remember, we've got a little bit of flex in the cutter, so we want to keep that in mind as we make our adjustment. Alright, let's go in for another check, blow our hole out. If you've got a telescoping gauge or another precise method for measuring the holes outside of the dial calipers, by all means use them. Okay, we're 1 inch and 42 thousandths. So we've got 8 thousandths to go. I'm going to go ahead and take 7 thousandths off in this next pass and allow for a thousandth of spring back in the cutter. Let's see how close we get. We're using a feed rate of 1.5 thousandths per revolution. We're entering now what we think is going to be our final pass. Retract our cutter and start it down one more time in case we've got any spring back in the boring tool. Looks like we're taking just a couple of tenths off in this last pass. let's take a final measurement now. I'm going to go ahead and lower the bed a little bit. Anytime you make any changes, make sure and lock the dial down so we can repeat our depth as we get a more accurate measurement. Okay, we're going to lower the bed 400 thousandths so we can get our dial calipers in the hole. Rotate our boring tool out of the way there. Okay, we're right on 101 inch and 50 thousandths, give or take a few tenths. So that's close enough for our work block. I don't want to see any blocks showing up for inspection that are an inch 55 thousandths, an inch 60 thousandths, okay? We're going to give you a little bit of leeway there, a couple of tenths. No, we'll allow 1.5 thou on that diameter. So pay attention, use a good sharp cutter. Remember to take into effect the spring back in the boring tool.